Hello FTC Alberta, welcome to the 2020 Build Blitz. It's a fancy way of saying we're going to try to do a robot in 3 days here, but we're going to do it in a little longer than 3 days because in what should surprise nobody, we are here in a Google Meet, or sometimes you're meeting in Zoom window, as we have in many ways for the last little while through the era of COVID here. So the Build Blitz isn't going to be 3 days, it's going to be a bit longer because your process this year, it's probably going to take a little bit longer. I want to welcome Navin and Nick, who are going to introduce themselves here. They've offered to help out with the first session here, so off you guys go.
Hey, my name's Nicholas Mccurry. I'm one of the FTAs here for our local FTC events. I'm a FIRST alumni, and I am addicted and love coming back to FIRST.
Cool.
Hey, I'm Navin. I'm also an alumni, and yeah.
Navin was one of our 7277 members for the Nelson Mandela Club as well. You have some mentorship background with one of our FTC teams as well.
Yes, I do. Whether it was good mentorship is up for debate.
Oh, come on, it was good mentorship. Navin was part of Peter Lougheed. You guys were 1471. I can't always keep all the junior highs up in the Northeast straight. 1471 5 or 6?
I think it was 5. Pretty sure it was 5.
Should remember these things. Anyways, here's the plan. We're going to talk our way through the initial stages of this Build Blitz. Because we have a problem this year, and a lot of mentors, a lot of teams have come to me as a first senior mentor. I guess I should introduce myself. My name's Mitch Way. I'm your first senior mentor. I absolutely love FTC, love FRC. I teach full-time robotics, absolutely live this stuff, and absolutely love this stuff. So my goal here is to walk teams through how you might be able to run a successful FTC season this year. And that's going to look different than most years. It's going to look completely different because we are in the middle of a pandemic. And so basically what this Build Blitz is meant to do is to answer the question of how do I run my team if I can't have my team meeting in person? And obviously we're having the first meeting here with headphones on through Google Meet, having an actual conversation about where this starts. Now kickoff for the season is in about a week. It's Saturday as we're recording this, and that means that we don't quite know what the game is yet. But you can still do some stuff to lead into your season, and that's kind of what today is going to be about. We're going to do some preliminary work around designing a chassis. We're going to do some preliminary work around talking a little bit about strategy in that sense, and kind of what we intend, what we kind of perceive is going to happen in... Yes, Emma? Yeah, go for it. Sorry, apologize. My daughter was interrupting there. But we're kind of going to go through what you would do in a build season where you couldn't have people together. And here's the model that I'm going to propose. And this is what I'm going to try to run with my teams personally. And it's the kind of the best way we've come to see as we might be able to do this. And what that means is that if we can't have more than, let's say, 3 or 4 people in the lab at a time, there is a way to break your team apart into all of the pieces that really make an FTC team function and have them work independently. And that starts with really good robot CAD. If we have a really good design for the robot, that's where everything can move from there. So here's my progression and what I intend on doing this year. We're going to do robot CAD to actually bring all of the details together in a basic design. We're then going to take, hello Emma, we're going to take the design from the CAD model and hand it off to a different build team. This could introduce more students to, Emma, I'm recording right now. Yeah, ignore that one. Thank you. You can introduce students to this from the CAD models, and that could be one team doing some of the designing. You can then hand that off to another group of students who can meet in person, maybe a small group of 2 to 4 people, and actually do the first pieces of the build. And I just want to say right now, a huge thank you to Studica, who's offered to send us some parts to actually do that piece of this build. We're going to go through the steps of actually designing and then actually assembling this robot. After that, that robot can be handed off to another small group of students who can do the programming, and that group can then hand your robot off to another group that's going to do your actual actual driving and actually compete with the robot. And this is similar to how engineering works in many ways, right? I mean, for the most part, the people designing the product are not going to be the people actually producing the product. So you're going to learn a lot about that process in going through the way that we do this. And with remote events, we can absolutely do this. Because what a remote event is realistically going to look like is you may have this field set up in your build space, and you're actually going to have that drive team being able to operate it from the build space during the week of the competition. Your programmers don't necessarily have to be there. They can be in a meet room like this, cheering on your team, watching the video, trying to keep everybody safe through the course of this pandemic. And I say that doubly so because I know a lot of schools are really fighting with this in terms of how do we do this within our safety protocols. Having something like that actually could very much fit within what you might be doing as a school. Now, I want to throw it to Nick, I want to throw it to Navin. What are your guys' experiences with FTC Drivetrains? What do you think? And also, predictions for Ultimate Goal, because we know the game name, and that's about all we know at this point. What do you think we might see? Because you've both been part of FIRST for a while, and you kind of know how these things cycle and how they work from there.
Yeah, so I don't want to get too much into the meta of the game and what's been released already, but especially with the fact that FIRST has said this can be played remotely for certain events, I don't think there's going to be a lot of robot-to-robot interaction in this game. I think a lot of it is going to be doing a task and doing it very well in a short amount of time. So I think, especially with it being Ultimate Goal, we're obviously going to have some kind of round projectile being shot into some kind of goal or target. But I think the focus for this year is going to be on optimizing that goal rather than trying to design for defense or offense.
Now, Navin, when you guys did the drivetrain with Peter Lougheed, what style of drivetrain? You guys were a first-year team at that point. You were a youth mentor at that point. But what did you guys do? What worked and what didn't with an FTC drivetrain?
I think we just went with a really basic drivetrain. I don't think we did anything too special, right? Just you got your 4 wheels with the 4 motors, and then
and
we put the.
You guys were part of Rover Ruckus for that one, so you guys were dealing with uneven terrain, which is something that kind of messes with it. Now, when it comes to drivetrains, couple things. FTC, I think Nick's assertion that there's going to be very little robot-to-robot is absolutely correct. I think that's a great guess. Basically, we have our main drive styles. We usually have some version of a tank drive. That's what the basic bot is, and so for any of you that are rookie teams, that's a really good place to start. There's absolutely nothing to... Oh, hello. Archit's here. I'm just going to pop Archit out here and send him a message to say that we'll introduce him later here. But basically the drivetrain, the tank drive, is something that's going to be your standard if you're a rookie team. Many teams aren't going to go there. With no robot-to-robot contact here, actually we're just going to invite Archit in here and just welcome him to the conversation. Archit, hello. We're recording this right now, so at the moment, just hang out here for a moment, and we'll bring you into the conversation here. We're talking about drivetrains. Just so you guys know, Archit is one of the recently graduated members of 7277, who has wanted to try to keep involved here. I believe you're looking at a computer science. You're of computer science post-secondary right now. That being said. We talked about tank drive, really simple, somewhat hard to maneuver, especially as a rookie team. The other ones you have access to are X drives, which were really popular for Skystone last year, and Meccanum. And those are both really good ways. We'll talk about both of those, or we've talked about those in the past. And they're actually cool ways of doing things, but they lack traction on the field. Nick can attest to this. FRC is a game of defense. You can run people over, you can play defense, body check all over the place. We absolutely love robots that do that, but at the same time, in FTC, that's usually frowned upon. A Meccanum drive is absolutely awful for pushing people around, and if you show up to one in an FRC competition, I almost guarantee you will be pushed around. It's just kind of how they work, and we were just talking about this before the broadcast that we both were part of. I was a mentor, and you were a student for the Recycle Rush game for FIRST Robotics, and it was an example of a game where robots didn't interact with each other. They actually didn't cross paths as it was, and there were a lot of Meccanums. Almost everyone used Meccanums that year for that reason. And I think for one of our bot builds this year, for the Build Blitz here, I think we will try to use Meccanum wheels for one of those, because that's absolutely a great way to do it. So those are your main drive styles: tank drive, Meccanum drive, X drive. There are a few other weird and wacky ones. I know the Discord was talking about H drive, which is where you mount a 5th wheel into the middle of your robot, and it can let you strafe back and forth for maneuverability, but that's kind of what we're looking at. Now, from a strategy perspective, Nick, what did you think for something like Ultimate Goal if we're, let's say, shooting a ball, for example, or shooting some other implement?
Yeah. I guess it'll really depend on what's coming out of it. I know in the past, FIRST has loved the use of their wiffle balls, so I think it's going to be some kind of semi-compressible small object that's going to be shot. in terms of shooter mechanism, I'm thinking it's likely going to either be like a flywheel or something else that's able to quickly accelerate it up into probably a raised goal, if not more of like a dozer design of just quickly gathering balls and pushing into a lower goal.
Cool.
But we're obviously going to have to wait to see what it's going to be like for that.
I like the predictions. That being said, the plan for here is to lay out the initial groundwork, and this is meant to be mimicked by another team. If another team wanted to get started a few days in advance of the actual challenge, this would be a really good way to do it. So we're going to go through the following. We're going to go into Fusion 360, and we're actually going to set up a shared folder. Now, the reason for this is your design team could be your entire team. It could be a large portion of however many students you have on your team. Everybody can have a piece of the design. In the past, I found that teams have people who really like their CAD and kind of become the core designers of the design team, and that's all good, but you still all need to be able to collaborate. It's not really a great idea to have everyone standing around in a Google Meet like this and all kind of throwing feedback into one person operating the mouse. We're going to try to make it so that we can work on designs in a little bit of a different way. So what I'm going to do is I'm just going to walk everyone through quickly how to set this up in Fusion 360. I just want to say, for those of you that haven't used Fusion 360, if you're a school team, you can actually get the, excuse me, you can actually get the free educational edition. I do recommend that. I do recommend the free educational edition. If you're a club team, you can usually get one for relatively cheap here. Nick, you said there was a non-commercial version you used?
I'll have to grab the details for that, but if you just Google Fusion 360 free non-commercial, there is still a way to sign up for that.
Absolutely. And so what we're going to do, I'm going to go into Fusion 360. I'm actually going to turn around and I'm going to set up, I'm going to show you the folder that we've set up. I'll show you how to set one up. We'll show how to invite team members into that piece, and then we're going to show Nick's screen, and he's going to show you how to access it as a team member. We're going to show you how to set up part files, how to bring them into a bigger assembly, and then we're going to talk about the two diverging projects that we're going to try to start up on this Build Blitz to go from there. So, welcome to Fusion 360, and at this point on the broadcast, we can't see anybody's cameras, we can't see anybody's screens, we're just looking at what I've got here for my particular screen. And my screen here, just apologies for a second, Emma, okay, you guys can hear Emma loud and clear, I'd assume, through the microphone?
Yes, we can.
Okay.
Yeah, I can hear you.
Hang tight for one moment here. I'm just going to mute my mic and... All right, and we're back. Okay, that being said, here we are in Fusion 360. Fantastic. Now you can see that I've got a ton of projects here down the left. I do a lot of this with my robotics classes. Absolutely love this program. That being said, what we're going to do is we're going to create a brand new project, and I've actually created the one we're going to use, but I'll walk you through the process. Once we've created a new project...
Honestly, I can't really see anything. I only see your face.
Oh, hey, fair enough. Let me go make sure that I share this with you guys. I apologize. The audience can see this, but you guys clearly couldn't. So let's get that piece fixed. I apologize. Clearly I'm new to streaming. Okay, you guys can now see Fusion 360, correct?
Yeah.
Fantastic. Now, I've created a new project here. This is, it's in my personal space, but it's a new project. I can name it 2020 Alberta Build Blitz, and we will do so right now. And once you've done that, you're going to end up with an empty folder. And that folder is the project. And that project can then be shared with people. You'll notice that I've got the empty folder here. If I go people, I am the moderator at this point of this particular piece, and I can go ahead and add people's email addresses here. And when I add those email addresses, and I'm just going to quickly add, another one of my email addresses here. You're going to see that it's going to actually add a new, it's going to send the invite, and then it's going to add a new person into here who can now share in on this. And I'm just going to go back a couple pages here. I'm going to go to the one that we're actually using for this year's Build Blitz, and you'll notice that I've already added a few folders here. That's just with the new folder button here. And I want you to, I want to go out here on a limb and say that if you are a new robotics team, or if you are an established robotics team, something you should endeavor to do all the time is to make sure that you have an effective file organization. And that means that you have separate files for your parts, you have separate files for each of of your designs, if multiple people are designing, that they put their folders in the right place and name them something appropriate for your team. You'll notice that we've got 3 folders here. It's our intent to actually have our part files in one folder, to do a more advanced robot, the laser bot, in one folder, and then to do a basic bot in the other folder, with the basic bot being aimed at you rookie teams, and the laser bot maybe those of you that have some more custom fabrication facilities in front of you. That being said, once you do this, you're going to see that you've actually got the names of the people who have been invited to actually work in this folder here. Now, the first thing you're going to want to do is get some part files. And what we'll do is, in the comments of this video or in the description of this video, I will link a whole library of part files. I try to keep these for FTC that are actually just files downloaded from Tetrix or from Rev or from Studica, who are kind of our main building kits if you've ordered from, I've ordered for FTC. Now I just want to take a moment here. I'm just going to hop back to the Google Meet for a second. And I want to just make my screen a little bit larger here and show you the difference between the Studica and the Tetrix kit. Now, most of you are familiar with the standard Tetrix channel, C channel. It's got lots of holes in it, so you can mount all sorts of things to it. This stuff is awesome. It's really good as a starter kit. It's one of the ones that I do recommend as a starter kit. This is the Studica Kit. Now you'll notice that it is very similar in terms of design to the Tetrix kit. It has some oval holes instead of round ones on the 45s here, but you'll notice that it is not quite the same size. So when we work with this stuff, you're going to see that you've got the difference between roughly 1 inch C channel and 1.5, it might even be a little 1.1 and 5/8 inch C channel. And the Tetrix tends to use imperial measurement bolts, usually number 632s, and the Studica one uses 3mm metric. So if you do have both kits, just make sure that you keep your bolts separate, because 3mm bolts don't like 632s very well, and vice versa. I actually recommend that a team pick one of them and stick with it, because they're very similar, but cause all sorts of problems in the threading. That being said, I've already gone ahead and uploaded the Tetrix, but I'm going to go and upload some of the Studica parts here, because they're also what we're going to be using for this build. For the basic bot, predominantly we're going to use Tetrix parts, because many of our rookie teams have those basic parts. They have Tetrix parts. Whereas I know some of our other teams might be looking for these Studica kits and actually integrating some of those. So in the Tetrix folder, you can see that I've already got all of the parts listed and uploaded here. And that is a good thing. I'll show you how to do that now. If we go back to, Build Blitz, go to our part files, and go to Studica, this folder is empty, but we do have the ability to upload parts. Now, obviously, I've got that library of files. You can see that I've got the Tetrix ones open, but I'm just going to go back and I'm going to go to the Studica parts, and I'm just very quickly going to grab a few parts that I might need to get started. I'm going to set up the rest of this folder. But as you can see, I have all of their parts, and these are the ones that we'll be using from the kit. So I'm just going to grab some C channel right now, get started, and upload this stuff. Obviously, I will upload the rest of this when we go there. Now, what you see is that it comes up with this upload file, or this upload window with all of the parts, how much they're going to take, what file type. We click upload, and life is good. You're going to see that they're going to start to upload into that folder until we have something that nicely resembles the Tetrix files here. Now, let's talk a little bit about how to make this actually work. We've got files, we've got parts, and we've got folders, and that's a really good start. It's a good place for us to get moving on this. But we want to start building a couple of different robots, and I'll just throw it back out there to Navin and Nick. Navin, what was your experience with the basic bot? And I'm just going to pull up the actual picture of it here. You guys built this with Peter Lougheed a couple of years ago, and I've got the PDF here of a very basic robot here, very basic tank drive. What did you guys find? Did you have to modify this at all through the season? How did it work for Rover Ruckus?
I think it worked decently overall. We definitely did make some modifications as we tested it out. So so we followed the guide first of all, the instructions, like your average Lego book. But over as we tested it and found issues, it would soon transition to a more iterative design, where we would change things, try it out, see if it worked or not, and then change it again over and over until we found a more optimal design.
Fair enough. And in a season like this, it's going to be that iterative design is going to look different, because obviously you're going to have your design come together, and it might be this base, it might be a different base, have it actually built by your team, and then if they find it doesn't work, it may have to be thrown back to the build team, and it actually might have to be redesigned or reconstructed from there. So let's pop back here and let's actually look at this, and I'm gonna assemble the first couple of parts of this basic bot. and just show everyone how to actually do this assembly in Fusion 360. After that, I think we're probably going to have a bit of a break here as everyone goes out and does some of their CAD, because the CAD does tend to get a little bit repetitive as things go along here. That being said, let's grab a couple of 416mm channels. Now you see that I have these here, and right now I'm staring at an untitled document. And that's not a great thing right now. I kind of, before I do anything, want to make sure I save this as what it's going to be. Now, you can create as many files as you want in Fusion 360 and drag them into each other. And that, I think we're going to illustrate that. I think I'm going to assemble a wheel hub and axle setup, and then I'm going to assemble a master file. So, the first file I'm going to create is going to be my master file. Now, what do I mean by master file? Master file is going to be your main file for CAD where kind of your final robot design lives. So let's go File. Actually, I have a new design here, so I really just have to click Save on this one. Now, it's going to ask me, what do you want to call it? Okay, I'm going to call this the Basic Bot Master. And I believe that both Nick and Navin are going to build a basic version of this just to practice some of their skills so that we can add stuff to it afterwards. So I'm just going to call this Navin's right here. And you'll notice that right now it's going to try to save this into the Tetrix part file folder. That's not what I want. So I'm going to go back here, and I'm going to go to my 2020 FTC Alberta Build Blitz, and I'm just going to go back a couple of files and go into my basic bot folder that I'd created before. That way this robot gets saved into the right spot. So I'm going to go ahead and save this. You'll notice that the name now changes to Basic Bot Master, and it's version 1 right now. We'll talk about what that means in a minute. But if I go to the basic bot, you can see that it's right here. I have it open, and I'm just going to show you how this works within Fusion 360 to actually bring part files in. Now I can go, and if the first part I'm going to work with is this 416mm channel, I can click and drag it over here. And it's going to show itself up in the master file. Now, this file is what we would call a reference file. It's actually referencing the channel here in the part file. And that's the key thing here. That means if I change the reference file in the part file, it's going to change whatever happens in the main robot. Probably won't be an issue with what we're doing because we're building the basic bot and we're just going to put a couple of wheels on this for now. So I'm just going to press OK. I can place it anywhere in my drawing. If it's the first thing that I'm actually putting in the drawing, it's not really important where it sits, though some people will tell you that they really like putting it at the origin at 000. So there we go. We've got our first beam there. Life is good. But we realize we want to have a wheel assembly here. So you'll notice that once I have this part here and I go ahead and save, I can click the save icon here. If I go back to my basic bot, you'll notice that this updated to show the newest save here. And it is version 2. It's the second time I've saved it. It'll keep counting versions, and it'll actually, Fusion will let you go back to previous revisions if you want to. I'm actually going to create a new file here. New design. And I'm going to name this, I'm going to save it as, in the basic bot folder, as wheel, hub, and axle. And I'm going to be even more specific. I'm actually going to put it as an Omni. And the reason I'm doing that is because, I should spell that right, Omni Wheel, Hub, and Axle. And the reason I'm doing that is because if we look at the basic bot, here, you'll see that the basic version of this is a C channel with a wheel, actually a few different kinds of wheels here. So I'm just going to scroll down until I get to the Omni Wheel, and I'm going to realize that in the Omni Wheel setup right here, the Omni Wheel is actually a few different parts. Okay, I've got a axle here, and I'm just going to assemble, I'm not going to assemble all the spacers for the sake of time here, but basically we've got our axle, where are we here? Bronze bushing, locking nut, I think I missed by one here. Okay. Oh, it's telling me how to assemble the Omni wheels completely here. Alright, so let's go ahead and get ourselves the axle collar, and all the numbers are on here as well as the Omni wheel and the spacer. So, let's do that. This is my hub and axle. I go back to my part files, and I go to Tetrix, and I go ahead and I grab my Omni wheel. This is a rather big file. It's rather complex. It's the entire assembly. And what you're going to see is when I drag it in here, you'll notice that I get the actual file here in the file folder. And if I open it up, actually, I can actually see the bodies that go into it. I can see that it's actually made up of a whole bunch of different smaller CAD files. And I can actually identify them. Every individual bolt, everything that goes into this is right here. So for some reason, my design calls for me to have an Omni wheel, but to remove half the rollers. I don't know why you'd want to do that, but you can actually make them go away right here in this breakdown, or this drop-down menu. Okay. That being said, I've got my wheel, and I'm going to go ahead and assemble it onto an axle. So I'm just going to grab my axle here. Let's grab, which axle do I want? Probably my steel axle. Let's just leave it 100 millimeters. Do I have any short ones here? I do not. Oh, there we go. There's the 6 millimeter axle I was looking for. Anyways, once I click and drag, you'll see that I now get another part here in Fusion. I can now do something with. I can move it around. I want it to be in a place where it's easy enough for me to work with. Now, the first thing, right now I've got 2 parts, and if I click them, I can just move them around wherever I want in my screen. This is your view cube up here for any who are new to CAD. This, by clicking this cube in the top right, lets you rotate around and see kind of all the things going on in this space. Just give me a moment here. Emma, can you go play with that upstairs, please? Thank you. That being said, I can move these all around, but I want to constrain them together. I want to make it so that they're actually tied to each other, not to necessarily the, wherever I'm clicking. So the first thing I'm going to do is ground one of these items. So I'm going to ground the Omni Wheel so that it can't move. I'm just going to leave it here so I can move stuff around it. I right-click on it in the browser, in the tab here, and I click ground. And I will capture position. When I capture the position, what happens at the bottom here is I get a timeline. The timeline is actually going to show me everything I've done to this drawing. If I'm creating something, I can see each individual step. But you can see right here, this little pin means that I've grounded the part at this point in the timeline in my process. I can't move it now. Click and drag, doesn't move. Axle, it still moves. No problems there at all. Now let's walk our way through a couple things here. This wheel doesn't actually need a hub on it. It's meant to be an idler. It's meant to just go. So I think what we're going to do is probably just try to put a couple shaft collars and maybe even a couple of spacers on this to actually make it functional here. So let's do that. Let's go with a couple bronze bushings. Yeah, why don't we do that? Okay, I'm going to drag a couple bronze bushings into here, and this is going to allow you to actually build your axle as it was. Now, you'll notice that I have this part. I know that this part to work is probably going to need 2 shaft collars and 2 bronze bushings, just because of what's in the actual guide for the basic bot. It might also need a couple of nylon spacers, but I won't add those right now. I'm actually going to take and grab this part and copy and paste, Control-C, Control-V, to put another one of these into place right about there. That's going to allow me to actually have the parts I need to work with out here in my build space. So let's put the axle on. The axle gets put on using the joint function that is up here in the top right-ish, and you have a bunch of options for joints. You actually have the option for rigid joints, revolute joints, slider joints, all sorts of things. Okay. For this one, for the sake of this part, we could put a revolute joint on, or we could put a rigid joint on. I'm going to use a rigid joint. What it asks us to do now is to select the position of our first component, and I could actually tie any piece of this together with the wheel that I wanted to, but I want to make sure that they have matching kind of axis of rotations here. So I'm going to click the kind of round end of the axle, and then I'm going to click the round end inside the wheel. And what you'll see is that it's going to try to join those things together. Now, in this case, I probably could do a revolute if I wanted to, a revolute joint. Excuse me. That's not going to work as well, though, for what we're about to do, and you just kind of have to play with this one to figure out what joints you want to use at any given time. I'll show you why in a second. Now, what I've got here is I'm gonna line this up about 35 millimeters halfway across the wheel here, so it's approximately centered. Your wheel may not end up that way. Now, from here, we're quickly going to go ahead and join the other pieces here, so we can go back to showing everyone how this works as an assembly. Then you guys can get to work. Any other fun FTC stories while I'm sitting here CADing, and you guys can regale the audience with? Navin, Nick?
Our battery flew out that one time.
Still got you here. Navin, by the way, for anyone who doesn't know, who's a rookie team, Navin is also one of our MCs for the FTC season, so he usually provides comic relief during the events. It's a lot of fun for that.
Oh, why would you say that? Now people have expectations.
Yeah, expectations are a good thing.
No, they're not. See, with a lack of expectations, I could do something and people will be impressed. But with expectations, if I do something, now there's like a rating bar and I have to fulfill that. Otherwise, people are gonna.
While we're here, I just want to
thumbs down
point
me.
out that the copy and paste thing does work after you've joined things, like after they're jointed in. So in this case, I put a I did put an axle spacer in here. You can see that here. It's showing up in my browser. I'm actually going to take this and I'm going to go ahead and copy it using Control C and paste it using Control V, and it actually gives me a new copy of that part that is not constrained. It's not joined anywhere, and so I'm actually going to go ahead and use that to put another spacer on here really quickly without going to dig in my part file. The part file you create on the copy and paste, it'll still be linked to the original file, and that just means that they'll be copies of each other, basically. And I'm just going to finish this, and then I want to show you a really cool piece of this, which for those teams that aren't going to be able to meet as often in person is going to be hugely, hugely important for you. Go. There we go. Okay, so I've constrained everything together, and I just did a rigid constraint right here. So I've got, I basically just have a wheel that in reality wouldn't hold up. It wouldn't actually hold itself together, but I'll explain what I'm doing here in a second. Actually, I just realized when doing this that I actually don't need my second bronze bushing. So I'm just going to click on it and delete it right out of the browser. Now, I've got a wheel. It's kind of grounded. It's constrained. It's where it is. It kind of is what it needs to be. I'm going to go ahead and save it. And I'm just going to quickly ask myself a couple things, because this is a point you might be like, well, how far away is this axle? How far is this going to hang out? You do have a button up here called Inspect, and the Inspect button is going to let you click on 2 points. So let's say I want to know what the distance between the inside of this axle is and the edge of this axle. And what you're going to do is you're going to be able to get a quick measurement for that. Now you'll notice that when it brings up the full menu here, you can actually see the distance in X, Y, and Z, because right now you can see I've got an angle on this. I've actually measured from one point to another. I really want to know just how far it is in this aspect. I can actually see that it is actually, it says 34.687 millimeters, but it's actually, it's 29.3 millimeters in just the straight linear direction here. Anyways, that might be useful for some teams when you're doing some measuring here and there, and I'll show you why. Because if I go back to my basic bot master here, I now don't need to bring individual parts into this file. I have an individual part right here, but I can actually bring in entire assemblies. So if I want to bring in the wheel hub with the axle, I can bring it right into this drawing, and I can start attaching it to things. Now, let's start playing with this, because now we're playing with things in virtual space, which is amazing. I'm going to turn this 90 degrees, and I'm going to try to attach it to this C channel right here. Now, I've got my axle here, and if we actually look at the basic bot and how it's attached, we've actually got the Omni Wheel on the end of an axle with a nylon spacer and a shaft collar, another bronze bushing spacer, shaft collar, and we're going to try to do something similar to this. But you'll notice that I've got a bit of a problem. My axle doesn't quite fit right now. So here's what we're going to do. We're going to take, and we are going to put, how are we going to do this? We're going to take and put the bronze bushing, and we're going to join it to the C channel using a Revolute Joint. Now, a Revolute Joint is going to allow it to spin. So watch this. Before I do this, I'm actually going to go ground my channel. Now, remember we talked about grounding. It means you can't move it in space. Right now, it can move. I don't want it to move. Right-click, ground, life is good. I'll capture position. Again, you can see at the bottom in the timeline, I'm getting kind of getting a picture of what I've done here. I'm going to actually ground this bronze bushing, and I'm going to ground. I can't see what I'm doing right here, so I'm actually temporarily just going to make my wheel hub go away by clicking on the eye here, and I'm just going to attach it into the end here. Now you'll notice that if I add this back in, I can now see that I've made the attachment for the bronze bushing. But the bronze bushing is joined to other parts in this assembly, so it's going to pull them along with it. Now, right now it's set to rigid. I want it to be a Revolute Joint. Now, if you notice, if I zoom in, there's a little thing actually spinning around inside there. That was not a great animation of it, but you can actually see there's a little bit of a piece spinning around in it, showing that it's actually rotating. When I press OK, it's going to actually resolve all of these things. It's going to bring all of the joints back into something that makes sense to Fusion, and it's going to pull the wheel with it. Now you notice something here. This wheel, it now spins. That's awesome. That's really good for illustrating, especially illustrating your mechanical design, especially if you deal with something like, a lift, a scissor lift, moving parts, lever arms, anything like that. But I do have a problem. On the bottom of this wheel, you'll notice that I've got a bronze bushing here. I don't have a bronze bushing on the other end, which I probably should have, and my axle hangs out way too far to this side. So this is where we get the chance to play with our designs a little bit. We're going to be able to add the rest of those things on. I'm going to use the inspect tool, and I'm just going to grab side to side, I'm actually going to grab the outside to the outside of this C-channel. I know that they're 30 millimeters wide. That's awesome. That means I know that space when I put my other bronze bushing into place. I also need to know that I need to slide this way the heck down. So let's save our design. Yep. And then let's go back to the Omni Wheel and let's fix the problem. So I got the Omni Wheel. I know this. Okay. And let's fix the first problem. I know that I want to slide this axle way the heck out of this wheel. So I'm going to go to my joints menu, which is right here. And I'm actually going to see that I've got 4 rigid joints. Cool. First rigid joint, if I double click on it, is actually going to go back to this original joint. Sorry, not double click in this. It is edit joint. Double click only works in Inventor, I think. Now, I know that this rigid joint was slid 30 millimeters that way, okay, and attached to this bronze bushing. It goes back to exactly when I made it. And I'm just going to slide it a little further down and see what happens. When I press OK, you'll notice that I've now moved this axle a little further down, and I can measure exactly what I need there if I need to. But right here, I'm kind of eyeballing this at this point. That's okay. Now watch this. When I press save, I've now changed this drawing. But this drawing is referenced in this drawing. And you'll notice what happened. I'm getting these big yellow yield signs, these hazard signs saying, hey, you don't want to do that. I did actually. What we're going to do now is we're going to go up to this link button here that says Get All Latest. This is going to update my design. And when I click it, you're going to see it's going to pull the most recent version of that drawing into this drawing. So I moved that wheel assembly back into place here. And you can see now I've got my axle. It's exactly where I want it to be. Okay, I probably have enough space to put the shaft collars as well as the 30 millimeter space bronze bushing on here. I'm going to finish this because this is something that as a team you should absolutely practice, you should absolutely go through in terms of building some CAD bases, some CAD things to work with even before kickoff happens. So I'm very quickly just going to grab this bronze spacer that's here. I'm going to copy and paste it. I'm going to slide it down exactly 30 millimeters, hoping that that will work. I suspect it won't, and I'm going to rotate it around 180 degrees. Now if I do my inspection right here, and I grab this here and this here, I will find out that it is 35 millimeters. Spinning it around 180 degrees meant things didn't quite work. So in this case, what I'm going to do, it looks a little skew-if to me. There we go. Okay, I'm actually going to go to joint, and I'm going to join these two things together. But when I join them together, I'm going to join them with an actual gap between them. And you'll notice that when I join those two things together, it's going to line and kind of mesh those two sides up. And I just realized when looking at this, it was trying to do a Revolute joint. All of my joints on this have been rigid, so I'm going to keep them rigid, because really this is just meant as a reference drawing. That being said, I'm going to change my position, and I'm going to offset in the X direction so that I have that gap. And I know that that gap has to be exactly 30 millimeters because I measured it earlier. So I'm going to go ahead and I'm just going to space those out exactly 30 millimeters from each other. I'm going to press OK. Now, what happened is this bushing here, the new one I added, got pulled into place 30 millimeters from this one, and this one didn't move because it is joined to something that is grounded. We can see that this is grounded, the little pin here in the big Omni Wheel. Now, those are exactly 30 millimeters apart. Because I'm a perfectionist here, I'm going to go to the part files, and I'm very quickly going to drop 2 shaft collars in this, because it's a good idea to actually finish these if you have the ability to. And I'm just going to go find, that is the axle hub with set screw. I believe that is the one. No, axle set shaft collars. There we go. Got the whole word right. I think Navin's probably having flashbacks on this one. This particular part here was one that in Rover Ruckus we used quite heavily up in Northeast Calgary, and these things didn't exactly like the edge of the crater too much. They were a little bit funky. Right, Navin? Navin?
Funky's a understatement. Probably the lightest way to put it.
Nick, you have any good stories about the basic bots for FTC?
Not many. Just a lot of times students not really remembering how tight some parts have to be. So, a shaft collar falling off or a wheel falling off in the field.
Nothing sucks more than the parts fall or your robot falling apart on the field. Navin can also attest to that. The 7277 robot, excuse me, had its battery bounce out of it in the middle of a match in Houston at the Worlds the one year. That was very unfortunate. Anyways, where I'm at with the CAD file right now, I'm just going to go save this, because now I actually have this thing, is this built actually matching what the basic bot guide says for an actual assembly for the front. I've saved it. I'm going to go back to my master here, and I'm going to actually click this button again to get the latest drawing, and what you're going to see is it's going to actually pull into place all the other parts. And just looking at this right now, I'm seeing there's a little bit of an error. I think I might have measured the inside to the inside, or the inside to the outside of this channel. I was using 30 millimeters, but let's check it again and see what we got. It's actually 32 millimeters. So I realize I made an error. So let's show you how to fix the error, because this is something that'll bother me otherwise. We go back to our Omni Wheel. We know that it was 32. We go back to the constraint that we used, or sorry, the joint that we used to create that gap, and I believe it was rigid 6. You can name these, by the way. So if you want to name these like gap between shaft collars or bushings, you can. I'm going to gap this or space this out to 32 millimeters, just like the measurement said, and press OK. Notice that it spaced everything out because I joined everything to the next piece in the chain, or in the chain of this drawing, and I press save. And then when I go back here and grab the latest drawing, you should see this piece here pop out, and that's exactly how you're supposed to set this up. Now, that's kind of the basics of Fusion 360, and it's the basics of the first set of this, or I guess the first step of this COVID team method, where people can come in and actually do multiple designs. And the reason we call this the Design Blitz is what's going to happen now is I'm going to send Navin and Nick and potentially even Archit out to go try to assemble the basic bot and actually build some basic chassis designs here. Now, guys, feel free. We're going to publish all these, so if there's anything in that basic bot guide that you want to change up, you want to move around, you want to make it your own, absolutely do it. We'll talk about that in a later video. Meanwhile, I'm going to actually take Fusion, and I'm going to do up a couple of pieces here around what a more veteran team that might have some fabrication spaces could do with their design. And in this case, I'm using the example of somebody who has access to a laser cutter and some plywood or maybe some ABS to actually do something a little more custom fabricated. Next week at kickoff, we're going to actually set up another video here where we actually do a build blitz on whatever mechanism we need to play the game. In all cases, I'm just going to throw out here, and I'll come back to everyone's video here in just a moment. I just want to point out that when designing a robot for a game like this year where we're probably going to be shooting for something, one of the strategy pieces I would definitely recommend, especially as a mentor, as a first senior mentor, whatever the case might be, is this open-ended piece is a really good idea. Because you're going to have to intake whatever the implement is probably off the floor. Having that open end allows you to pick something up from the floor itself, if you can think of that, where we can actually pick something up from the floor level and bring it up into a shooter of some sort. Because, I mean, we all kind of said, we think we're going to shoot something. The game's named Ultimate Goal. It may as well be. That being said, we'll come back for some videos on some more advanced CAD techniques. We'll come back for some more videos to show off what everyone's created in their CAD. And then next week, we'll build some stuff to actually play this game that is this year's FTC game in advance of you guys doing some remote events this time around. Any last words, Nick? Navin? Anybody want to pile in here?
No, just best of luck to the teams for this upcoming season, and yeah.
Fantastic, guys. We'll see you later.